Okay, so I'm back with the answer to that more challenging problem. And if you look, that's where we were. And here's the math for it. So you should have gotten 113 thirds. If you didn't get that, you need to go back and check your math. Okay, so that was one challenging one. Let's do another one where you have three functions, and we need to find all those intersections so we can see what's going on. But this is one where you might have to split it into pieces yourself. It's not automatically split in pieces, and you'll see what I mean. I'm going to draw my graph kind of in the corner because I know this is going to happen mostly in the first quadrant. So I'm going to draw my graph there. So 8 over x squared. Okay, now do you remember what 8 over x squared looks like? That's going to look like this graph and this graph with asymptotes here. And so does it say like what the region is bounded by? No, they're just bounded by each other. So we are not sure where we are, but we're thinking about that. Y equals 8x is just going to be through here like that. It's probably steeper. And then y equals x. Well, I drew y equals x, so of course y equals 8x would be steeper. So it looks like this little chunk is what we're going to be looking at. Okay? So let's see if we can't get some better points. I'm going to leave that y equals x squared. Well, okay, I'll get a few points off of it. But first, let's just graph y equals x. So we're going to just go for it here. We're going to say that's y equals x. Might not be exact, but that's y equals x. And then we're going to say we want y equals 8x. So that means I would go up 8 and over 1. So instead of 1, so it's going to be much steeper. 1, 2, 3, 4, 5, 6, 7, about here. So I'm going to do this. And I have 8x. Not supposed to be curved, but here, let me undo it. Shoot. Okay. Okay. There's 8x. Okay. And we know our graph's going to come around like this, the other one. And so this is the area we're talking about. So they didn't give you a left bound and a right bound like a bracket because they're included in this shape. So what's weird about this, though, is I'm going to take a black marker and show you. If I'm trying to do what's top on bottom, I have an issue because it switches like, okay, right here, like if I'm going this way on x, as x goes to here, this is definitely on top, this function, and this function is on the bottom, right? But then right here, so I'm going to draw that in, this function becomes the top function with the same y equals x line being the bottom. So we have like a piece here. Oops. This is like piece 1 and piece 2. And I hope you could see that. I kind of went slow. So make sure you understand how I was trying to find out. From here to here, I'm going this way. So it stops what one's on the top. So you know what I need? I need the intersections. So the first intersection I know that it's 0, 0. Because we're talking about y equals 8x and y equals x. So this is definitely point 0, 0. So I know that I'm going to have from 0 for my first integral. And it's going to stop right here. Because that's when this curve graph becomes the top. So I have to find that, and that is the intersection of y equals 8x and 8 over x squared. So let's set those equal to each other. So 8x equals x squared. Okay, so No, it's not 8x squared. It's 8 over x squared. Sorry. 8 over x squared. So 8x cubed equals 8. So x cubed equals 1. So x equals 1. So this is at 1. And if you want to figure out what the other point is, you can put 1 in. So it's at 1/8. So this is 0.18. So I know that it goes from 0 to 1, with the top one being the 8x and the bottom one being x. So there's my first integral with piece 1. This is piece 1. And now I have to add, so I'm going to erase this stuff over here for now. I am going to add this second piece, and that piece would definitely go from 1, and I have to figure out what this intersection is. This point. So this point, the x, I need like the x value of that point. So I will put that's y equals x and 8 over x squared. So x cubed equals 8. So x equals 2. So they're pretty nice giving us these numbers. So it would be 2, 2. So happens at 2, 2. Okay, so my second integral is from 1 to 2. And the top one this time is this graph, the curved graph, which is 8 over x squared. And the bottom one is minus x. So, take a long time. Not that bad, though. Had to split it up. Again, you could find all these intersections on your calculator if you could use it. You would put these 3 functions in and use your calculator. But you got to be able to do it by hand also. All right, so I'm going to get rid of my extraneous stuff here. And let's go ahead and do the calculations for this. Okay, so let's see, I have them written out. This would be, simplify it, 0 to 1 of 7x dx. That's nice. Plus 1 to 2. And let's put this all together in one. Well, no, I think it'd be easier to do it separately. This is 8 x to the negative 2 minus x dx. Okay, so now do the anti-differentiation. That would be 7x squared over 2 from 0 to 1 plus, okay, this would be 8, and then that would be x to the negative 1 over negative 1. So now we have negative 8, over x minus, this is the second one, so kind of do like that, negative 8 over x minus x squared over 2 from 1 to 2. So this would just be 7/2 minus 0. That's nice. And this would be putting in 2. That would be plus negative 4. Let's see. Negative 8 over 2 is negative 4 minus 4/2, so 2, and then I have to subtract that from 8 minus 1/2. So you get 7/2, and this is ends up being negative 8, sorry. Should be negative 8. So you end up getting 7/2 plus 5/2. Sorry. That's what it should come out to be. Equals 12/2. So you get 6, believe it or not. The area of into those curves is 6. Okay. So I'm going to stop the video there. That was the second one, or I guess third video.